Woo! Math! I love you, math! Math! Wow! You know what makes me happy? Math! Area of special quadrilaterals. Here we go. We've got the area of a rectangle. Pow. How many spaces high? 1, 2, 3, 4. That's the width or the length. By how many spaces long? 1, 2, 3. Oops, 1, 2, 3, 4, 5, 6. So this is 4 by 6. So that would make us have how many squares are in a rectangle. So if it's 6 rows of 4, or wait, no, 4 rows of 6, then you can add it all up and you get 24. Shortcut is area of a rectangle is length times width. I like to do this little abbreviation where it's the area of a rectangle is equal to length times width. Area of a square, well, what's special about a square? Oh, both sides are the same length. So if you're looking for the area of a square, instead, you could use the same formula as a rectangle, because what is a square? It's a specific type of rectangle. So really, length times width is correct. But it's nice to remember that a square has the same length sides. So I could actually abbreviate it down to area of a square is equal to side squared. So actually, if I knew the area of a square was, say, 25 square units, what would be the length of the side? Well, it'd have to be 5, because 5 times 5 is 25. Area of parallelogram. Well, in actual reality again, guess what? A rectangle is a parallelogram. It's a specific type. It is one with right angles. So a parallelogram is really length times width. But since sometimes they're not with 90 degrees, we also like to have a more specific one for parallelograms. I'm going to take this green one, and what I'm going to do is I'm going to move the top side over 2. So what's happening, how I like to visually think of it, is this triangle here, I basically got rid of and cut out, and I moved it over to here. So it's a 2 by 4 triangle, right triangle, and all I'm doing is cutting it out here, sliding it over here, and putting it in here. So this green parallelogram is actually the exact same size as the original rectangle. So it still has a base of 1, 2, 3, 4, 5, 6, but the height is not this diagonal. The height is actually the right angle. So it's up 4. So this green parallelogram has exactly the same area as the rectangle. And it is, again, 6 times 4, which is 24. In fact, I could even move it over more, make it even more diagonal. So I could make it even more diagonal, and it still has a base of 6, and it still has a height of 4, and it would still have an area of 24. So if I was to take this and move it over, it looks like 1, 2, 3 spots, I would then need to move this over 3 spots. So now the question is, the rectangle is still 4 by 6, so if I move it over, this is 4 spaces, and the height is still 1, 2, 3, 4, 5, 6. So this green parallelogram I put in here still has an area the same as the rectangle, which is 6 times 4, 24. Next is the area of a trapezoid. So do you remember what a trapezoid is? A trapezoid has 2 sides that are parallel and 2 sides that are actually not parallel. You can have one of the sides meet the bases at a right angle. You can even have the 2 other sides going the same direction. They just cannot be actually parallel. It can only have one set of parallel sides. The parallel sides are the bases, and that's how you know. Now, not all parallelograms are going to be this base here and this base here. It might be tilted on its side, right? And you have your formula, which you can go ahead and write down, and I'll explain why that formula works. We have a parallelogram. It's got 2 bases, and I know that those are the bases because those sides are parallel. I could have also done it this way, and this is the same exact trapezoid, okay? I could have drawn it this way, and it's the same exact trapezoid. It doesn't matter, okay? The trapezoid could be any way. I know we're visually used to seeing it like this, but the biggest base could actually be on top. The one thing that's important is that the two bases must be the parallel sides. So what I'm going to do is I'm going to encompass this in a giant rectangle. What we're going to do to figure out the area of just the trapezoid is we could do a couple different things. One option is we could figure out the area of the rectangle and then subtract these two. We could start with that just to really trust what the size of this trapezoid is. So if I did that, the full rectangle is 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4. So the area of this full rectangle is 9 by 4. Which is 36. And what I'm going to do is I'm going to take off this triangle and subtract this triangle to figure out what's left is the trapezoid. So the area of this other triangle on the left is, let's see, 3 by 1, 2, 3, 4. So what's half of 3 times 4? Remembering how to find the area of a triangle. 3 times 4 is 12. Half of that is 6. So this is 6. And the area of this triangle over here is equal to 2 by 4. So 2 times 4 is 8, but it's half of that, so that's 4. So if we take the 36, that's the full rectangle, subtract 6, we get 30, and subtract 4, we are down to 26. So hopefully you guys all agree that the area of this trapezoid is 26. So the goal is, can I prove that again? One way I like to think of it is I have this base that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and the other one that's 4. So what I like to do is sometimes find the average of the two bases. So why am I saying the average? Well, because I want to find basically this rectangle that's somewhere in between those two sizes. You know, it doesn't stop here and it doesn't stop here. It stops somewhere in between, and same here. What that would look like is this rectangle here on this side would actually only come out half this distance. So what you'll notice, and this side's going to be hard for me to hold, but what you notice on this other side is this little triangle here is basically flipped over and taken here. So it's the average of those. If I took this triangle that's here and turned it and put it in here, then it would have made a triangle, or excuse me, a square, a rectangle. And I could do the same sort of idea here. Remove this triangle and put it down there, and it'll average out to a square that's this size. So this square is 6.5 by 4 tall. So if I can figure out what 6.5 by 4 tall is, because that's what that average rectangle is, 6.5 times 4. Well, I know 6 times 4 is 24, and half of 4 is 2. So if I do 24 plus that extra 2, I do in fact get the 26, which is what we said the trapezoid would equal. You can also plug it into the equation to prove that it's true, right? If I plug it in, 9 and 4 is 13. The height was 4, so I do half of 4, which is 2, times what 9 plus 4 is, which is 13. So 2 times 13, again, equals 26. So a couple ways to prove that the trapezoid formula does actually work with half of base 1 plus base 2 times height. Please remember, this is base number 1 and base number 2, not base to the first power and base to the second power. These are subnotes. So there's two bases, and this first one's just called the first one, and the second one is the second one. All right, thanks much for listening.